Hello students, I hope all of you are fine. Today I am going to discuss about chapter 6, that is triangles of your textbook. In this chapter the most important theorem, Thales theorem. Today in this session I am going to discuss about this theorem, the statement of the theorem and how to prove it. What is the meaning of the word proportional? As you must have done in class 7 and 8, the chapter ratio and proportion. The meaning of the word proportion is whenever I say two ratios are there, suppose A and B, this is one ratio, and C is to D, another ratio. Whenever we say the two ratios are equal, say A by B equal to C by D, then we say the numbers A, B, C, D, they are in proportion. Let me explain the statement of the theorem. As you can see here, if a line is drawn parallel to one side of a triangle, just concentrate in this part. If a line is drawn parallel to one side of a triangle, let me draw one triangle. Suppose the triangle is A, B and C. And as it is, if a line is drawn, if I draw a line like this, which is parallel to this side, intersecting the other two sides are these two. So this line has intersected this line, suppose at D, and this line at E. Then the other two sides, this side and this side, are divided in the same ratio. That means in this triangle ABC, DE is parallel to BC. Then this part, that means AD by DB will be equals to AE by EC. Let ABC be a triangle in which DE is parallel to BC, DE is parallel to BC, such that DE is intersecting AB at D and it is intersecting AC at E. Fine. Now what we have to prove? We have to prove that this ratio, that means AD by DB, this is one ratio, and AE by EC is another ratio. These two ratios are equal. So this is what we have to prove. So directly I cannot prove. We need some construction. First thing that we have to do is to join BE and CD. So we have joined BE and CD. So after joining BE and CD, we have to draw two perpendiculars. From E, I have drawn one perpendicular. This angle must be 90 degrees. EP is perpendicular to AB and DQ is perpendicular to AC. So I have written here BE and CD are joined. BE and CD are joined. EP perpendicular to AB, EP perpendicular to AB, and DQ perpendicular to AC are drawn. Now I am going to start the proof of this theorem. Initially we are concentrating in the triangle ABE. ABE. So I have drawn it separately, ABE. As you can see here, two triangles are there, ADE and BDE, and this is the perpendicular which is P here. EP is perpendicular to this line. For this triangle ADE, which is the height or altitude, EP is the altitude. Similarly, for the triangle BDE, altitude or height is EP. Now, if you take the ratio of the area of the triangle ADE and the area of the triangle BDE, we know area of a triangle is half into base into height. So, for this part, area of triangle ADE, it will be half into, for this triangle ADE, which is the base. AD is the base, you write AD is the base, and altitude is PE. So here you write PE is the altitude. Right. Similarly, for the triangle BDE, it will be half into base. Base will be BD. But altitude, as I told you, for both the triangles, altitude will remain same. So P is the altitude. As you can see here, half and half you can nullify. P and P can nullify. So you are going to get AD by BD. Let it be equation number 1. Now, if I consider the other part, that is triangle ADC. So I have drawn here ADC. Actually, here you can consider one triangle here, ADE, and lower part DEC. Just like before, for the upper triangle, altitude or perpendicular is DQ. Even for the lower triangle also, perpendicular is DQ. That means for this triangle, lower triangle, this is the base, then this will be the altitude or height. Now, if I find the area of triangle ADE by area of triangle DEC. We know area of a triangle is half into base into height. For the upper part, we can write directly half into AE into DQ, and for the lower part, it is half into EC into DQ. Well, all of you know the area of a triangle is half into base into height. So here half and half nullifies, DQ nullifies. So we are going to get AE by EC. This is equation number 2. The last part of the theorem, that is, we have to consider this part BDEC. As I have drawn here BDEC, it consists of two triangles. BDE, one triangle, and second triangle is DEC. As you can see, both the triangles are on the same base, DE, and between the parallel lines, DE and BC. In class 9, you have done one theorem that triangles on the same base and between the same parallels are always equal in area. So here, BDE, triangle BDE and triangle DEC are on the same base. What is the base for both the triangles? BDE, DEC. Base is same, that is DE. And between the parallels and between the parallels. Which parallels? DE and BC. DE and BC, as in the between the parallels D and BC. Therefore, area of triangle BDE will be equal to area of triangle DEC. This is our equation number 3. From equation 3, we got area of BDE and area of DEC are equal. So if we take the reciprocal of them, I am going to get 1 by area of BDE equal to 1 by area of DEC. Now multiply both sides by the area of the upper triangle, that is ADE. So I am going to get area of triangle ADE by area of triangle BDE equals to area of triangle ADE by area of triangle DEC. Now just see equation number 1. From this part we got AD by DB equals to area of ADE by DEC. See equation number 2. There we got AE by EC. So once we have proved it, that means your theorem is proved. I hope you have understood the theorem. Now try to do some sums related to it. The concept will be 100% clear. Thank you.